Z30?
Yes, ma'am.
Yes, please repeat in 2 sentences.
Ma'am, first of all, if we speak of the definition of the order of the element, then we know that if we have a group of G comma star, where star is in operation, then the order of an element A, which is belonging to G, will be A to the power m, means A star A. This way it will go. So number of times the A is operated with the operator star will be for which we get the uh, to say for which we get the
Identity.
identity element of the group will be our order of that element A. So
Very
here
good.
so here we're finding the order of the element 18. So here you have to find how many times we are operating after how many times we operate 18 with the operator here it is plus means plus modulo, so addition modulo. So how many times we'll operate 18 with addition modulo, so that we get the identity element, that is 0. So we can see that
After
if
dividing by
we
30.
yes ma'am.
How many times I will add 18 and then divide by 30 and get the identity element 0?
Yes ma'am,
I have to
that's the
divide
thing.
by 30 also.
Yes. So here we are seeing that if we add 18 five times, 18 plus 18 plus 18, if we add the 18 5 times, we are getting 90, and we know that 90 is divisible by 30. So here we can see that after adding 18 5 times, we are getting the and dividing it by 30, we are getting our identity element 0. So here
Very
we
good.
can take
Yes.
so from here we can find that the order of the element 18 will be 5.
Yes. Thank you so much. Okay. So this was one explanation actually, and the other one is given here, which will be given to you in your Google Classroom also. So you have a choice. You can go for that or you can go for this. Okay. So please spend some time on this slide and look at the questions done here and how you find the order of the element. But I have already taught you how to find the order of the element. So you can go by that simple method also. Or here, what they have done, they are saying that the common factor of 18 and 30 is 6. 18 is the element and 30 is nothing but the total number of elements. And then they are dividing 30 by 6 and they're getting the order as 5. Okay, so that's up to you, whatever way you want to go about it. Anyone having any question in this?
Ma'am, one doubt I'm having in this.
Yes.
Ma'am, saying that you're saying that at the end we're dividing by 30. So I want to say I am having one doubt here. Means
Mm.
we know the definition of addition modulo is that when the addition of, suppose we're having two elements A comma B, and we are having a group, suppose G comma plus modulo, where this group we're having, and A comma B are the two elements of the of this of G. A and B are two elements of G. So as per the definition, A plus G, if A plus G is less than the less than n, means suppose plus modulo to the power, we're taking plus modulo, suppose 4, suppose. So here will be, means if A plus B is less than 4, then it will be as it is. But if A plus 4 is greater than 4, then we will be doing that A plus B minus 4. So this is the definition of plus modulo to the power plus modulo 4, right?
Mm.
If I'm taking n equal to 4 here.
Mm. If it is less than 4, whatever is at the numerator, that is your remainder.
Yes, and if I am taking A plus means if my A plus B, if the summation of the two elements A plus B is greater than 4, then we will reduce it by 4 every time. And suppose
If
I
it
am
is
having,
more than 4 after dividing, whatever is the remainder, that is your answer.
and that isn't for multiplication modulo. The
No,
division part is,
multiplication means how many times you multiply 18 and then divide by 30 to get the remainder. That is multiplication. That is the difference between multiplication modulo and addition modulo. In addition modulo, I'm adding 18 5 times and then I'm dividing by 30, and I want to get the additive element to find the order. Okay, so the additive element is 0. So in multiplication modulo, I am multiplying 18 how many times and then dividing by 30 to get the multiplicative identity, which is 1. That's the difference. Actually, I'm not sure what you are asking.
I am going by the definition of addition modulo.
Yes, but what is the query? First, you tell me that. The definition of addition modulo is clear to us, but I mean, you are having some doubt somewhere regarding it.
Yes, ma'am, regarding this addition modulo, because
Yes.
I've learned that if A means if A plus B is less than N, then
Yes, you
we're
take an
reduced.
example. You tell me, say, in this
Okay,
case,
ma'am. Okay, ma'am.
what you
Say
want actually.
I'm taking Z4. All right, I'm taking Z4. So here my set will be 0, 1, 2, and 3. And here
Wait,
my
wait,
plus
let us go to Z4 because we already have Z4 here. That slide is here. Wait. Yes, this is my Z4. The elements are 0, 1, 2, 3. Yes.
okay. So suppose I'm taking here two elements, one and no, sir, I'm taking suppose 1 and 3. Okay. So if I'm applying plus addition modulo 1,
No,
1
you
and 3,
cannot apply 1 and 3 addition modulo. You have to first understand. Addition modulo is an, what you say, operation. Okay, 1 and 3, fine. Wait, so 1, this is your addition modulo 4, 3. Okay, let me understand. This is what you want to find the value?
yes, ma'am. It will be uh, 4,
This 4 will
which
be
is
little small. Addition modulo 4 is the operation. Okay, so 1 is
ma'am,
one element and 3 is other element. You want to know what is the value of this?
it will be 0, right?
Good, let us do it. So what we do actually for
Okay.
addition modulo, we first add 3 on 1. Okay, so 3 plus 1 and I divide by 4 and I want to know what is the remainder. Whatever is the remainder, that is my answer. Okay, so 3 plus 1 is 4. So if I divide 4 by 4, the remainder is 0. So if since the remainder is 0, the answer to this is 0. Here you tell me, do you have any doubt in this calculation?
No, ma'am, no, ma'am. Actually, I did this in the other way. No, you're right. You're right in your part. I just, learned this in other way. Around
No,
means
but
I'm
you
what
will
I'm
get
doing.
the same thing. Addition
Yes, ma'am.
modulo, yes, tell me.
What you have said, that's completely right. Means I have learned it in the other way. The way I have learned is that if here we can see that 1 plus 3, which is 4, means here A plus B is less than equals to N. So whenever it is greater than equals to N. So whenever it is greater than equals to N, I have to reduce by N. So here N is equals to 4. So we're getting 4 minus 4 I'm doing every time. So it's coming as 0. I have learned it this way. So both
Fine, we are
concepts
getting
are
the
right.
same answer. No problem.
Yes, ma'am. Yes, ma'am. Both are
Yes,
same.
both are same,
Got it, ma'am.
isn't it?
Yes, ma'am. It's fine. Got it, ma'am.
In that way, both are same. Okay, so just check on this. If you have still any question, you write it to me in the chat. I will think and again I will ask you back. I mean, I will answer you back. Okay, write it in the chat.
I,
Okay.
I got it, ma'am.
Okay. So Ria, what you were asking about it, we add 18 5 times, then divide by 30. We are adding 18. Yes, because we go for the least actually. If you add 5 times and it is divisible, we stop there. You can add 10 times, you can add 30 times also, no problem. You can add many times, but we go for the least number. See, this is the definition actually which says that we go for the least integer. So for Zn, for this referred to as a group of integers modulo n, that what least is somewhere. We have to check actually. Anyway, so we go for the least number of elements actually to add and get it. So that answers Ria your query. So you are adding the least number of elements. So 5 is the least number of elements actually in this case, which we add 18. I'm adding 5 times. Okay, that's the least number of times. That upper side, the lower range is 5 times. If I add upper, to can go on and on. Okay, you can add so many times, and still you can divide by 30 and get a remainder 0. Okay, I think you got it. Okay, still anyone has anything, you just write it to me in the chat. We will answer you. Okay, finding the generators of Z12. This I had discussed in class before, so I will not go into it. Then we have one more question about Z9 and Z27. I will not discuss again because I told you about Z24, 15. So same things are there. Now you know about the generator. Now you know about the subgroup. So this is the same explanation. The entire PPT will be uploaded. So please go through all of this to get common question in your exam. You should be knowing about Z24 and 15, about Z9, 27, Z30, all of this. So today I'm giving you all the questions actually. So please prepare for all these, actually all the generators and the subgroups and whatever information about the order of the element and this, that, then you can expect everything to come common in your exam time. And that will be quite helpful. Okay. Now we have few slides. Whatever I was saying, same things, but it's from a different presentation. And I don't remember which university actually just now. It's there in the net only. But these few slides I found quite interesting to sum up whatever we were speaking till now. Okay. So a cyclic group is a group which can be generated by one of its elements. That's fine. So that we have discussed so many times. Okay, this color will not go here. Let's change it to blue. Maybe blue will go. Yes, blue will go. So G is equals to a to the power n, such that n is an element of Z. Actually, n belongs to the set of integers. That's what they're saying. A belongs to G is more important. Or in addition notation, it is Na. So we have told you in addition notation, it has to be Na and then a to the power n. And if A is the generator, we write it like this. So this is the definition of a cyclic group. Then I have some examples that both 1 and minus 1 are generators of Z. This is simply Z. Okay, the set of integers Z under ordinary addition. So not addition modulo n. So under ordinary addition. So if I am considering the set Z and I am considering ordinary addition, okay, then in that case both 1 and minus 1 are the integers, are the generators. Okay, so how this is how it is giving. If I add 1 once, I get the first element. If I add 1 2 times, I get the second element. It's in the form Na and not a to the power n. That you have to keep in mind. Similarly for minus 1, so these two are the generators for the set of integers. So for objectives, you should know this, okay, that 1 and minus 1 are the generators of Z, the set of integers under ordinary addition. And hence it is cyclic because you have generators like 1 and minus 1. Okay, then they're talking about the Zn group, which we have also discussed so many times. There's an example about Z8 and the generators. Just go through this, what they're telling you. 3 is the generator for Z8. Then you have U10 and its generators discussed. U8 is not a cyclic group. This we have explained you already in previous class. The generators of U10 are given. I think I gave you one question in the assignment. Question number, oh no, U8 is not cyclic and U9 is cyclic, not U10. Okay, so that I think you have already U9 also somewhere, so find out. Okay, so here U8 is not cyclic given and U10 is cyclic. Every cyclic group is abelian. You do not need the proof of the theorem. Z plus is a cyclic group because it has a generator 1. Z30, the subgroups, this we have already discussed and showed you also, given you in the assignment. Okay, from Herstein, there are few questions actually. You can look at it, it's interesting. With solutions, of course, I have given you. So you have certain questions like U8 is not a cyclic group, U9 is a cyclic group, U17, U18, U20, 25, 27. So very lengthy ones not required, but I have just given you the list and the solution. So you can go through the solutions of this, how this is cyclic, that is not cyclic, and so on. So since the PPT will be given to you, I am not going into the discussion of all this. So just go through this set of questions. Okay. So for this part, it's fine. There is one more notes I would like to show you. Okay, there is one more doc file I have with you, which I would like to share with you. Okay, so it starts with what's a binary operation, closure property, groupoid, but the examples. This is why I want to share with you this. Okay, I will give it to you in the Google Classroom. Look at the examples. So whatever objective I give, you should be knowing. So groupoid is all this. Okay, n minus is not a groupoid. You have to keep in mind. Okay, groupoid means the closure property must hold. So in case of subtraction and the set of natural numbers, closure property does not hold. We know that. If I take 5 and 7, 5 minus 7 is a negative number and it doesn't belongs to n. Then you have some examples of semi-group. Okay, so with respect to n, z, q, r, c, all of them are given. Where it is semi-group. Okay, so generally it is with addition and multiplication. For subtraction and division, you can check none of them are semi-group. So this small doc file is very good actually for your understanding purpose. Then we have what is a group that you know, abelian group, finite group. Z plus is an abelian group. Then we have some solved examples like Q plus is an abelian group, R plus is an abelian group. Example 4. The set of complex numbers C has been chosen under addition of complex numbers. And they have shown you the closure property, identity, associative, inverse, all. Okay, so just go through this. It's interesting. Example 5. Non-zero rational numbers. Okay, so rational numbers but non-zero. That means 0 is not there. And the operation is multiplication. And then they have moved with closure, associative, existence, and inverse. Example 6, non-zero real numbers. Okay. Example 7, non-zero complex numbers. So these are all abelian groups. Okay, this is only group, this is abelian group. So just check on. Okay, this is the question in the assignment you have, which is solved here. Only this is not 4 actually, this will be G. So G is equals to 1 omega square, where omega square and 1 are the cube roots of unity. So this forms a group under multiplication. So just try with this, form the composition table, closure property, associative property, identity, inverse. Just check on what they have done. I will be giving you this. You can just go through this till abelian, all the 5 properties. Then example 12, we have G is plus minus 1 and plus minus I. Shouldn't we give an example while proving the properties too? This is an example only, no? Already it's given. If you are talking about this, it's already given that the cube roots of unity 1 omega square forms the set G. And you are showing that under multiplication of complex numbers is a group. Pranay, can you be a little bit clear on what you are asking? Example of what? Which one you are asking? This itself is an example only, example 11. This is in your assignment. You can tell me, just unmute yourself. Yes, but it is, okay, no problem. You cannot unmute, but see, it's done now. Yes, yes, it's better you give an example. Now I got it. You take 3 elements. The elements are 1 omega and omega square. You please add them and you get the values and you show. Yes, that's correct. Yes, for closure, yes, you take examples and show. Very much correct. Yes, thank you for noticing this. Because identity and inverse they have done, but this they have just written. So better take and show. That's very much required. Okay, so plus minus 1, plus minus I. Similarly, actually closure property, no need to take example. You just say that all these, how many 9 elements are 1 or omega square. Hence it is closed. Okay, because after you show the composition table, it is very easy to talk about the closure property. And similarly for the associative law, you just take some example and show. You take 3 elements and you add them by changing the brackets, the orders, and you just show that they are equal. Okay, please take examples. So how will I know that you have proven in the table? You have to write that. No, these all the elements in the composition table are elements of G, so G is closure matter. This you can write and complete. That's understood. Okay. Yes. So associative law only you have to show. Because in the composition table it's shown, right? You have already done it. And you show that, you say that these all the 9 elements are either 1 or omega square. Hence it's closed. Okay, that's correct. Very good. Okay, example 12, we have 16 elements here. This also we had done previously. So you just state the closure property that since all the 16 elements belongs to G, it's closed. Associative log, and they haven't taken any example. You should take 3 elements and show, then identity and inverse and so on. Okay. Okay, this is a big one. Plus minus 1, plus minus I, plus minus JK. Too many elements, 1, 2, 3, 4, 5, 6, 7, 8. No need of such a big example, because we are more interested in quality and not quantity. Okay, so there is no need to do such a big one. But you should know that this is called Hamiltonian group. This is for your general knowledge, or the group of unit quaternions. Its order is 8 because there are 8 elements. Okay, so plus minus 1, plus minus I, plus minus j, and plus minus k. And the Hamiltonian group is a non-abelian group. Okay, so let's not put a cross here, because okay, these informations you can know. We don't like so much calculations, but we are interested in informations, no problem. So the Hamiltonian group is non-abelian under multiplication. This example you can keep in mind. Addition modulo m, this you know very well now with all the examples we have done previously. Multiplication modulo n, this is also done. This example 14 was discussed in class, G plus 6. And the next example was also done, G plus 7. Okay, under addition, under multiplication. I took it from here in this only, and I discussed in the PPT. You should know it, Shobhajachi. Okay, I cannot give anything objective. Okay, but there can be objective questions where you require actually which properties are important for ring and field. So only the notes I have given you. I cannot ask you something that you prove it is a ring or prove this is a field. But you have to know, suppose the operation is multiplication, and you are checking the property, say closure property. So that will be for ring theory, that's required. I mean the basic definition you should know. That's all. So for ring and field, which are the properties applicable, that should be right. That field you have all 5 plus 5, 10 properties. What's a commutative ring with unity? Okay, I mean which are the properties required there. So the knowledge is important. Maybe not all the solving power, because that is not possible to check in an MTA question. But like this, no such a big calculation I can never give you. But there can be an objective, like the last one I had crossed because so big. But what's an Hamiltonian group? It can be a part of an objective question. Okay, that it is non-abelian, this much. Okay, so like this, small informations you should have with you. We don't need very big informations. Okay, then there are some theorems actually that your inverse is unique. Then another was there. Identity is unique. So theorem 6 says that inverse is unique. Inverse of inverse gives you back the element. You don't need the proofs. Just go through the statements of the theorem. That's all. Okay, so that's all we have actually. So focus more on the solved examples just now for your MTA. Exercise maybe not that much required immediately. Okay, so there are many solved examples. So just go through the solved examples. So if there is anything, any one of you have anything to ask? So you have that one more PPT to go about with, which contains the subgroups, the order of the elements, and such type of questions. And this one, a general one, easy, simple one. And regarding ring and field, you don't have much, only you should know what is it. That's all. Suppose there is some MCQ based on it, you should know the basic definition, that for how many properties ring is required and for how many properties field is there. That's all. And how it is different from group. That's all, like things like that. Okay, so that's all I have for you today. I will be taking your attendance now before we end on. Okay, you are asking me which question? 5 part 3. Question 5 part 3. Just wait. Okay, question 5 part 3. 9 multiplication modulo 1 5. Isn't it? This is the question now. 9 multiplication modulo 1 5. This one. Okay. So that means, yes, I will upload today only. Don't worry, I will not waste your time. I will just upload it today. I will give you everything today only. Okay. So this will be, that means I am multiplying 9 into 5, 45. And I am dividing by 5. And I want to know what is the remainder. Actually, you have an equal sign here, but it is the remainder. The remainder of this. Okay. This is the meaning. We are going for the remainder of this. So 9 into 5. Okay, sorry. Divide by 1, not 5. It is multiplication modulo 1, no. So it is divide by 1. So 9 into 5, divide by 1. What is your remainder? That is what is happening. So if I divide 45 by 1, my remainder is 45. So this is my answer, 45. So just check if you have understood this. Multiplication modulo 1. That means remainder after dividing by 1. Pranay, have you got it? Pranay, have you got it? Okay. Is there anyone else? Any other question? It is the remainder that when I'm dividing 9 into 5 by 1. The remainder is 45. I said wrong or what? You are not correcting me also. What is the remainder? When I divide 45 by 1, I wrote wrong. Yes, the remainder is 0. I am also actually tired after there were many classes today. If I am dividing something by 1, it is exactly divisible, isn't it? Yes, the remainder is 0. You have no remainder, no. With 1, it is exactly divisible. Okay, sorry, Pranay. So this is your correct answer. As it is, you were confused. I confused you more actually. Your friends are there. They have given the right answer. Okay. So if I am dividing 45 by 1, my remainder is 0. Okay. So final answer is 0. Okay. Thank you so much. So if there is anything else anyone who wants to ask, otherwise we end today's class here.